This is SpaceTime, Series 28, Episode 24, for broadcast on the 24th of February 2025. Coming up on SpaceTime, the odds narrowing for an Earth impact by the city-killer asteroid, looking at the origins of the Moon's Grand Canyons, and NASA's stranded Starliner astronauts coming home earlier than thought. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA says there's now a 3.1% chance of Asteroid 2024 YR4 slamming into the Earth on December the 22nd, 2032. That translates to odds of 1 in 32, up from the 1 in 43 or 2.3% chance of an impact earlier this month, and roughly 3 times greater than the original estimate of 1 in 83 or 1.2% first calculated 4 weeks ago. The 40 to 90 metre wide asteroid is now the most threatening space rock this big ever recorded by modern forecasting. Astronomers have estimated its size based on its brightness. 2024 YR4 is on an elongated elliptical orbit around the Sun. It's currently moving away from the Earth, making it more difficult to track. But it will be back in December 2028, where scientists will get a good look at it and be able to finalise its orbit and trajectory. The last time an asteroid more than 30 metres wide posed such a significant risk to Earth was Apophis back in 2004, when it briefly had a 2.7% chance of Earth impact in 2029, a possibility later ruled out by additional observations. 2024 YR4 was first detected on December the 27th last year by the El Source Observatory in Chile. The International Asteroid Warning Network issued an alarm on January the 29th, after the impact probability crossed the 1% barrier. The agency says if that risk rises to over 10%, it'll issue a formal warning, leading to a recommendation for all United Nations members who have territories in the potential impact zone to start terrestrial preparedness. The potential Earth impact site lies along an arc running from the Central Eastern Pacific Ocean across northern South America, then the Atlantic Ocean and equatorial Africa, before finally ending in northern India. Professor Fred Jourdain from the School of Earth and Planetary Sciences at Curtin University says that while the odds of an impact are still incredibly low, the threat is not so small that it can be easily ignored.
Well, I think the latest news is really about the increase of probability that it's going to smash on Earth, and it's still very, very low. I think I've read a news somewhere that there's even a 0.3% chance it would impact the Moon, so it's even lower.
We don't know whether it's a rocky body or a rubble pile. I guess one of the interesting things is issues of planetary defense. Now, we've had the DART mission by NASA, so we know a little bit about planetary defense from an asteroid, don't we?
Yeah, so that mission was absolutely excellent. I mean, it really showed us that by smashing probe into asteroids, we can push them. But it also shows us that we don't push them a lot. Right. So it takes time to really push an asteroid out of the way, because the weight of the probe is fairly low and the mass of the asteroid is really high. So you need to smash many probes if you want to deflect a big enough asteroid. Now, in the case of YR4, it's fairly small. It's between 40 meter and 90 meter. That doesn't seem very big, but that could level easily a city. So that's something to consider. Pushing it away, destroying all these safety measures that people are considering. And you mentioned the structure, and this structure is absolutely important. The structure, the nature of the asteroid, it's very important to know what we can do to prevent an impact. Let me give you an example. If it's a hard, rocky body, and you try to impact a big enough object or even detonate a nuclear bomb, there's a huge chance that it's going to fragment. Now, if it's a rubble pile asteroid, some study we did at Curtin really showed that if you detonate a nuclear bomb, not at the surface, but near the surface, then it would withstand the shock and be pushed away. And maybe this kind of measure, this kind of approach is more efficient for deflecting an asteroid very quickly than impacting probe over time, because in the case of YR4, it's going to come back in 2028 and then again in 2032, and that's when it could potentially impact. So that's a really short amount of time to be able to push it out of the way. That's why it's important to consider all the technique we can use to deflect this asteroid.
Yeah, I remember we did an experiment like this on a small scale. We had a boulder and we had a rubble pile, and we fired a 223 rifle into each of them and hit the boulder, and it moved the boulder. But when the bullet hit the rubble pile, it just went right through, and the rubble pile stayed where it was. It didn't really move the rubble pile.
This is absolutely correct. I mean, that's something to really keep in mind is like, well, if you detonate a device at the surface, you would fragment the big one, and I don't know what it would do to the rubble pile in space. But the shock wave from something that is detonated sufficiently far away, you know, those people, they make the calculation, not too close, not too far, very brilliant engineering. And if you do that, then the rubble pile will be easily pushed away without theoretically fragmenting it. Because obviously, if you fragment the asteroid, you transform a single ball into many, many pieces. It's and like instead of a bullet, instead of a bullet, now you get a shotgun spread. So if it was supposed to hit the ocean and now you fragment it, and now it's going to rain on every city on Earth, I mean, you know, not every city.
Along the flight path,
along the flight path, exactly. Then people are not going to be really happy, you know, less damage, but still a lot of damage, whereas before there would have been nothing for this particular city. So there's really an ethical concern like that to consider.
Let's assume it's a solid body. That's not going to airburst. That's going to cut through the atmosphere. It's going to go all the way to the surface. What sort of damage would something that's, say, 90 meters across do on the planet?
Well, that's why we call it the city killer, not the country killer or the planet killer, because it's fairly small, actually. If people want to imagine what it would do, it's like detonating a powerful nuclear bomb. It's the same. An impact is an explosion. It's not really like digging a hole. It's just an explosion. And, well, unfortunately, you know, in our history of humankind, we detonate a lot of weapons as a test everywhere on the planet. And, you know, depending where it's done, it just leaves a hole in the ground. And the hole it would leave, it would be the size of Arizona crater, the Barringer crater, which is about 1 kilometer wide. So that's not that big. However, a city would be completely level. So here I live in Perth, and we have roughly 2 million inhabitants, and the city would be completely destroyed. Now, it would have been a bit of warning before so people can evacuate, but still it's really not nice to lose a beautiful city like Perth if you want. But considering the bigger implication, not much. I mean, you know, it's not like you're going to have a nuclear winter or anything like that. Plus, something that people need to consider, Earth is covered by about 70% water. So you get 70% chance it's going to land on the ocean. And the land is about 2% inhabited in terms of cities. I mean, you know, of course, there's people living in bush and stuff like that. But in the term of cities, it's about 2% coverage. So there's very low chance it's going to impact on a city, much more like in the outback or something like that. Well, not that it's on the flat plan, but like you're related to Australia. So the chance is really small. And I would say for scientists, you know, we almost would hope that it would impact so we could study how things happen, because there's going to be so little consequence. But again, in middle of the ocean, it's safe. In the outback, it's safe. Unfortunately, if it's on a city, that's really not good news. And that's why we need to learn to deflect asteroids. Maybe not for this particular case, but, you know, for the training purpose, not waiting the absolute last minute to know how to do something. And our first test is our first practice. That's not reasonable, I would think. So using this opportunity, maybe try to deflect this one. That would be interesting. And I think I might be wrong, but I think I read online that China is interested by the prospect of doing that, having their own dark mission using another asteroid and maybe this one as well. So we'll see how it goes.
The other option, of course, is that it is the rubble pile, and that makes me think more of the Tunguska-like event.
I know what you're saying, like a big explosion in the sky. It's still
like Tunguska or Chelyabinsk.
Chelyabinsk was really small. It was a small one. It was 10 meters in diameter. minor, but still, broke a lot of windows and things like that. But impact, asteroid like that, explosion, it's really a exponential scale. So 90 meter is not 9 times more powerful. It's so many more times powerful. Like I said,
logarithmic.
Yes, 500 times Hiroshima or something like that. So that's really decent. Rubble pile or not, I think that would be the same thing. If the explosion touched the ground, okay, it's one thing. But if it explodes in midair with the power of nuclear bomb, that has exactly the same effect on a city. That still level it the same way. So rubble pile or not, it's more for how we're going to deflect it, which is important, rather than how it's going to impact on Earth, in my opinion.
That's Professor Fred Jourdain from the School of Earth and Planetary Sciences at Curtin University. And this is SpaceTime. Still to come, looking at the origins of the moon's Grand Canyons and NASA's stranded astronauts now likely to come home a little bit earlier than last planned. All that and more still to come on SpaceTime. A new study has concluded that 2 gigantic canyons on the moon were most likely carved out by streams of impacting asteroids over a space of just 10 minutes. The new findings, reported in the journal Nature Communications, are providing fresh insights into an area of the moon which will be crucial in upcoming lunar missions. The Schrodinger impact basin, with an estimated age of 3.81 billion years, is located in the outer margin of the moon's 2,400 kilometre diameter South Pole Aitken Basin. That's one of the largest impact basins in the solar system. The Schrodinger basin itself is surrounded by canyons and ravines, created by streaks of rocky debris known as ejecta rays that were flung out during an impact event. 2 spectacular canyons in the complex are Vallis Schrodinger and Valles Planck. These massive canyons are comparable in size to North America's Grand Canyon, with Schrodinger measuring some 270 kilometres long and 2.7 kilometres deep, while Planck is even larger at 280 kilometres long and 3.5 kilometres deep. However, the exact nature of their formation had always been unclear until now. The new research is based on images of the moon's surface used to generate new topographic maps, which were then used to calculate flow directions and speed of the debris ejected during the canyon-forming impact event. And these data could then be used to model how the ejecta rays were formed. The study's authors proposed that these lunar Grand Canyons were carved out of the lunar crust in less than 10 minutes by ejecta travelling at speeds of between 0.95 and 1.28 kilometres per second. They calculate that the energy needed to create these massive canyons would have been over 130 times the energy of all the current global inventory of nuclear weapons. Rather than flying out symmetrically, the work suggested the majority of the excavated debris was asymmetrically distributed away from the poles. The Schrodinger impact basin is close to the exploration zone for the upcoming Artemis man-moon mission. So these findings will have important implications for future lunar missions, possibly offering insights into the composition of potential landing zones. This is SpaceTime. Still to come, NASA's stranded astronauts Suni Williams and Butch Wilmore, who have been stuck aboard the International Space Station since June last year, could be returning home earlier than currently planned. And later in the science report, it's official, La Niña has finally arrived in the eastern Pacific Ocean. All that and more still to come on SpaceTime. NASA astronauts Suni Williams and Butch Wilmore, who have been stranded aboard the International Space Station since June last year, could end up returning home earlier than currently planned. That's because SpaceX is looking at swapping the Dragon capsules for its next 2 manned missions to the orbiting outpost. That would see the Crew 10 mission launch on March 12, 2 weeks earlier than previously slated. Wilmore and Williams have now been stranded on the space station for over 8 months on what should have been an 8 to 10 day mission, after problems developed with the thrusters aboard their Boeing Starliner spacecraft, which was undertaking its first manned test flight. NASA were concerned about safety issues with the spacecraft, and Boeing eventually decided to return the spacecraft to Earth unmanned. It ended up safely landing on the White Sands Missile Range. After the new Crew 10 arrives on station, Wiltmore and Williams will return to Earth with the current Crew 9 team aboard their Dragon capsule, which will be fitted with 2 additional couches for the astronauts. This is Space Time. And time now to take a brief look at some of the other stories making news in science this week with a science report. Well, after 7 months of waiting, La Niña, the cooler and wetter sister of El Niño, has finally arrived in the eastern Pacific Ocean. However, a report by NOAA, the National Oceanographic and Atmospheric Administration's Climate Prediction Center, has warned that La Niña may not stick around for very long, with the Pacific likely to return to neutral conditions either next month or in April. Part of the El Niño Southern Oscillation or ENSO cycle, La Niña appears when energized easterly trade winds intensify the upwelling of cooler water from the depths of the eastern tropical Pacific, causing a large-scale cooling of surface waters in the eastern and central Pacific Ocean near the equator. The stronger than usual trade winds also push warmer equatorial waters westwards towards Australia and Asia. And this dramatic cooling of the ocean's surface layers affects the atmosphere by modifying moisture content right across the Pacific. The new report has confirmed that La Niña conditions are now present. It measured sea surface temperatures 0.7 degrees Celsius below average in an area of the tropical Pacific known as the Niño 3.4 region. And the signature of La Niña is also visible in the central and eastern Pacific Ocean as areas of lower than average water levels. That's because cooler water contracts, lowering sea levels. Conversely, warmer water expands, increasing them. La Niña causes shifts in the path of mid-latitude jet streams in ways that intensify rainfall in some regions and bring drought to others. In the western Pacific, for example, rainfall usually increases over Australia and Indonesia. Clouds and rainfall become more sporadic over the central and eastern Pacific Ocean, which can lead to drier conditions in Brazil, Argentina, and other parts of South America, and wetter conditions over Central America. In North America, cooler and stormier conditions often set in across the Pacific Northwest, while the weather typically becomes warmer and drier across the southern United States and across northern Mexico. A new study warns that if you lose your sense of smell or taste in adulthood, especially for saltiness and sourness, you may well be at risk of dying prematurely. The findings, reported in the Journal of the American Medical Association, followed 7,340 people for around 6 to 7 years, 662 of whom reported losing their sense of taste. Now, during the study period, 1,011 of those participating died, resulting in a background chance of dying of 14%, or around 1 in 7 people. But for those who lost their sense of taste, the risk of dying during the study period was around 47% higher, or around 1 in 5. The biggest increases in death risk were among those who stopped being able to sense salty tastes, as well as among men who stopped being able to taste sourness, and among women who stopped being able to taste bitterness. And that increased risk of death was seen even among people who had lost their sense of taste but whose sense of smell had remained intact. So, it seems, although it's yet to be proven, that a loss in taste could serve as a simple way of scanning high-risk populations in order to determine who's at risk of dying prematurely. Now all we've got to do is work out why the association seems to be there. Paleontologists have rewritten the evolution of dinosaurs after discovering fossils of the world's oldest known megaraptoid and the first evidence of Carcharodontosauroids in Australia. The findings, reported in the Journal of Vertebrate Paleontology, has changed the history of theropod dinosaurs, uncovering a predator hierarchy unique to Cretaceous Australia. The research describes 5 theropod fossils discovered along Victoria's coastline, unearthed in the Upper Strzelecki group between 121.4 and 118 million years ago, and from the Umarella Formation on the Otway coast between 113 and 108 million years ago. These fossils are offering scientists new insights into Victoria's ancient ecosystems. It was a time dominated by large, powerful 6 to 7 metre long megaraptoids, smaller 2 to 4 metre long Carcharodontosauroids, and small, agile metre long southern raptors. The discovery also shows how Victoria's predator hierarchy diverged from South America, where Carcharodontosauroids reached Tyrannosaurus rex-like sizes up to 13 metres, towering over the megaraptoids. But in Victoria, the roles were reversed, highlighting the uniqueness of Australia's Cretaceous ecosystem. A fraudster who claimed to be able to cure a range of illnesses using a so-called slapping therapy has been jailed for 10 years in the UK after one of his patients died. Tim Mendham from Australian Skeptics says the conman had used the same scam in Australia, where another patient died.
Slapping therapy is one of those treatments for disease, etc., which people make up, oh, I've got a good idea, maybe we should try this. There is something close to it, but not quite the same. It's been around a while called tapping therapy. You tap parts of the body, just tapping with sort of like 2 fingers, and that's supposed to help your health. No evidence for that. But there's a one which is a lot more serious than that. It's slapping, as in literally slapping the face and slapping the body hard. And it's sort of developed by a Chinese fellow named Hongqi Zhao, and he was doing it in the UK. He came to Australia and was doing it there. What he suggests is that this is better than medication. This has a real effect, he says, and it's better than medication. And in some instances, specific instances, people who need insulin have been told not to take it. And when you don't take the insulin and you have a bad case of diabetes, it can have immediate or very short, almost instantaneous effects. And what happens is that if you continue not to use it, it can be fatal. And that's exactly what happened in Australia with a young lad. I think he was 10 years old. His parents were going through the slapping. I don't know if the kid was, but the parents were. And this person was suggesting, don't take insulin. It's bad for you. The slapping will do all the things you need to do. So they stopped the insulin for the kid, and then pretty soon, within a few days, he was rushed off to hospital and he died in a most agonising, horrible way. He started vomiting. He started coughing up bile. All sorts of terrible things happened. So he was charged in Australia. He was found guilty, sentenced to 10 years, but he got off on appeal, mainly because of legal technicality, not because he was not guilty of slapping in a way, but just saying the trial wasn't exactly as it should have been, and therefore they're going to have a retrial. But in the meantime, he had actually moved to England and was doing the same thing there, and with the same result of another older woman there who was suffering from diabetes, and she thought he was a messenger from God, which is the way he portrays himself, and same problem, insulin stopped, and dies in a terribly agonising way. So he's moved around from place to place and doing the same sort of thing, and now been thrown in jail in the UK. Sounds like a silly thing, slapping someone for medical reasons. Yeah, you get a red cheek and it might be a bit painful. What harm can it do? Well, it can kill you.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.